Hi, it's Robin. Viewer Matt T suggested I make a video about writing Hello World for the Commodore 64. Sometimes I get suggestions that are way too difficult, like, why don't you make a tutorial about making a MMORPG for the C64? Showing the Hello World program almost seemed too simple, but actually it's exactly what people search for online when they're wanting to learn about a programming language or environment. And actually earlier this year, I remember seeing some people like Retrocombs asking AI chatbots like ChatGPT how to write a C64 Hello World program and other simple examples. And some of the answers it gave were terrible. They looked kind of right, but they were wrong, like really, really wrong. Here's some examples of the terrible, broken, useless code that ChatGPT can generate. Just pause the video if you want to look at them in detail. At least for these examples, I think GPT stands for Garbage Producing Technology. ChatGPT does not test the code it gives you. Sometimes it's close to correct, but sometimes it's horribly wrong. So I'll try to do better than that. If you'd like me to make a video about how terrible ChatGPT can be, let me know. So today we'll be writing Hello World on the Commodore 64. Even though it's extremely simple, we'll start with BASIC, as trivial as that is, and then we'll look at 3 different ways of writing that same Hello World program in assembly language, or machine language, or machine code. I'm sharing 3 different ways rather than just one, as I think the multiple approaches will give extra perspective that you might find useful. Not only will we look at alternate Hello World code, as there's many ways of programming it, but also a variety of ways of entering it into the computer, or development environments, if you might want to call it that. They're not necessarily practical, but I think they'll still be educational and hopefully interesting. As always, I'll add chapter indexes if you want to skip around, and there will be a downloadable D64 if you want to play with any of this code or the environments yourself. Okay, so first, just Hello World in BASIC. Just turn on your Commodore 64 or emulator, or actually any Commodore machine that boots to BASIC. And then, here we go, just type a line number, such as 10, to indicate that this is a program and not something you want the computer to do immediately. Type the command print. You can include a space if you want. Then double quotes, which is Shift-2 on a real Commodore 64, or if you're using an emulator, it's often located down in this area now. And then just type whatever you want it to print, such as Hello World, closing quote, even though that's not strictly necessary. Press return, and there you have written Hello World. And then you just type the run command and return, and it will do exactly that. It printed Hello World, and it returns to the ready prompt. Okay, it's really that simple. This BASIC is an interpreted language. BASIC stands for Beginner's All-Purpose Symbolic Instruction Code. And really, this is a big part of the appeal of these 8-bit computers, that you just turn them on and they're ready to go to program. And especially the Commodore machines with their full screen editor that allow you to just cursor around, not just a command prompt that just keeps forcing you further down the screen. You can actually go back and revisit your code and modify it and then just press return again. I've made a lot of videos about Commodore BASIC. I'll link to a playlist of them in the video description. Okay, moving on. Might notice I've got a Kung Fu Flash plugged into my Commodore 64 here, courtesy of The Future Was 8-Bit and Kim Jorgensen. If I press reset, you'll notice I have a Super Snapshot ROM installed here, but down the bottom left corner, this is ROM version 5.31 NTSC. This is an unofficial update to Super Snapshot by my friend Adrian Gonzalez. And if you want to run this on your Kung Fu Flash or Easy Flash 3, or even in your original Super Snapshot, if you want to burn a new EEPROM, I'll include a link in the video description. But basically it's Super Snapshot, but further improved. One of the major features is Turbo Macro Pro is now built in, just press F5 and it'll launch right into Turbo Macro Pro. And there we are in our development environment. You can also use this in an emulator if you wish. I should make a video about this in more detail, but for this next example, we'll be using Turbo Macro Pro. So it's either available through the Super Snapshot version 5.31 or later, but you don't have to use that. But if you prefer, just load up that D64 that's in the video description. And there's a program here called temp, TMP. Load that, TMP, 8, 1. It'll take a little while to load. And once the ready prompt comes back, SYS 32768 to start. Either way, get to Turbo Macro Pro, which is an integrated editor and 6510 assembler. And that's what we'll be writing the first of our assembly language hello worlds in. So let's type in live, star equals 1000 hex with a $sign in front. This is the origin of the assembly, telling the assembler where in the memory space to assemble the code to. And we're choosing $sign, that means hex 1000, which is the same as 4096 decimal. We don't have to use that value, but for our purposes, that's totally fine. That's normally in the large empty place where Commodore 64 BASIC can be stored. Then we're going to load the X register with the immediate value. That's what the number sign or hash means, 0. So just initializing the X register to 0. X is one of two index registers that the 6502 has, X and Y. And it just has the one general purpose accumulator, which we call A, and that's it on the 6510. I may say 6502. The Commodore 64 has a 6510, but it's just the same as the 6502 processor that's in the Apple II or the PET, with the addition of an input-output port. But it's totally code compatible, 6502, 6510. Next, we're going to put a label called loop. And this is going to be our main loop that prints each of the characters in Hello World. Next, we're going to load the accumulator with the value in memory location text, which is just a label that we'll define shortly, indexed by the X register. So this is just loading the accumulator with the value at memory location text plus X, which is just currently 0. And now we need to check for the end of the string, so we're going to branch if equal to another label, which is called done, and we'll define that shortly. So basically, we're going to 0 or null terminate our hello world string, and when we do reach that 0, it's going to branch if equal to 0 to our code at done, which we will write shortly. Next, we're going to jump to subroutine FFD2. And this is the Commodore 64 and actually all 8-bit Commodore computers with something called the kernel operating system. This is their print character routine. It prints the character that's stored in the accumulator out at the current cursor position on the screen. If you wish, you could define character out as FFD2, like that, and then jump to subroutine character out, if that makes you happier. But most Commodore programmers just memorize FFD2 because it's unchanging between all the systems. Now that we've printed one character, like the H in Hello World, we're going to increment X. So X will go from 0 to 1, and we're basically done. We're just going to branch if not equal to 0 to loop. The 6510 doesn't have a branch always command. We know that X is going to be greater than 0, so this is effectually a branch if always. If you prefer, we could do a jump loop, but that uses an extra byte. And finally, we're going to do that done label, RTS to return from subroutine. That's just going to return to whatever called this little program. And that's the end of the code. And now we're just going to add some data with the label text, which we referred to up here. And we're going to use the text pseudo-op, which allows you to define a string of characters, which we want to print to the screen. And in there, we're just going to type in our hello world string. And then to null terminate it, we're just going to put a byte pseudo-op 0. So the assembler is going to put that hello world text into memory at location text, which this is going to be able to look up in that loop. Okay, and then it's going to end with a 0. So that's our whole program. Ready to test it? Back arrow 3 assembles it, and there's no errors. And I'd actually like to run this from basic, so I'm going to drop out back arrow 1, and here we are in basic. Control 2 switches the cursor color to white, just so it's more visible. And now we're going to just run that program, but it's not basics. We're not going to use the run command that we used earlier. Instead, we're going to use the sys command, which calls assembly language, and we assembled it to location 4096 decimal, which is the same as the 1000 hex. Okay, here we go. We're going to call it, press return, and there we go. It prints out hello world and returns with the ready prompt ready to go. Let's clear the screen. And to re-enter the assembler, sys 32768. And here we are back, ready to make changes if we wanted to. Okay, so that's hello world in 6510 assembly language using this particular Turbo Macro Pro assembler. Back arrow asterisk shows the disk directory. I just want to draw your attention to example 1, back arrow load, example 1. And here's a version that's exactly the same code, but I've put a whole bunch of comments in there in case that helps you with understanding it. And then back arrow L, example 1 space NC for the no comment version. Just going to reset and exit to basic. One of the nice things about using a Super Snapshot ROM, F3 just does a disk directory. And we've included here a SuperMON program. So we can load SuperMON plus 64, 8. And this is the second environment we're going to use. We looked at assembly language. This is what we might call machine language, which is one step closer to the actual machine code and has less niceties. But this is actually what I learned on. Let's run it here. You see here it says SuperMON plus 64 by Jim Butterfield, and it gives the address to restart it if you want, sys 38169, just in case you exit the program and you want to start again without reloading to preserve memory. Yeah, I did a video about a monitor very much like this for the Plus 4, and I'll include a link in the video description to that if you want to learn more detail about what all this means here. But just for the purposes of writing hello world, first we're actually going to prepare the data. So I'm going to clear the screen, shift clear, and up in the top corner, I'm going to type in hello world. And a trick, instead of pressing return, which we'll try to process that as a command, give an error, just hold down shift and return. And now if we type in M, that's the show memory command, and type in the address 0400, and this is showing the contents of memory at location 400, which is actually screen memory. So this is showing us what is up here, hello world. It's showing us the actual contents of memory, and these are called the screen codes. 8 is for the H, 5 is for the E, 0C, which is 12 decimal, is the screen code for L, and L again. 0F is 15 or O, and 20 is a space, and so on. When you do the memory command, it displays the memory, but it also puts this modify memory command, this is that greater than symbol, right there. So if you want, you could just type in and modify this to anything you'd like, So actually we'll use it and we'll just type in the address C100, and now it will enter these numbers into this memory location, which is just up out of the way, C100. And here we're going to change this to C108. And now if we clear the screen and show memory at C100, you see those same values, 8, 5, C, C, F, and so on, are up here at C100. I've chosen that kind of arbitrarily, but the area at C1000 to CFFF is often empty and available for your own little machine language programs. Note that it's not free in Turbo Macro Pro. The assembler actually uses that for its own purposes. But here in SuperMON, this is a different environment, this machine language monitor from Jim Butterfield, it's available. And we actually need to do one more thing, is that here after hello world ends, D is the fourth letter, so that's the last. Instead of this 20 hex, which is a blank space, we're going to put a 0 there, as we talked about before, just to null or zero terminate the string. Okay, so now that's done. Now we can write our machine language program. And there is a simple assembler, non-symbolic it's called, and you'll see what that means shortly. So we're going to assemble to C000 or C1000, as I like to say, maybe incorrectly. Okay, so I'm going to load A with immediate mode plus, which means decimal, otherwise it defaults to hex, plus 147. 147 is the PETSCII, Commodore's ASCII, PETSCII code for the screen clear, 147. And you see the assembler has right away has changed that to 93 hexadecimal. That's the $ in front. And it's also immediately assembled the load A into the A9 opcode, which means load A immediate. So that means load A with hex value 93. This is what a simple assembler like SuperMON does. It immediately assembles each line, which I guess in a way is nice, but it also means that you can't do nice things like symbols, that is, labels. At least it knows load A, and it understands immediate mode and conversion from decimal to hex, but that's about it as far as features go. Okay, continue on with our program, and it also automatically is going to assemble to C002 now, the next available memory location. And we're just going to jump to subroutine FFD2, which just prints the clear screen. And you see how it's automatically moved on. That was a 3-byte instruction. 20 is the machine code for JSR, and location FFD2 it does in low byte, high byte format. So it looks like they've been swapped around, but that's just how the 6502 deals with 16-bit addresses, with the low byte first, and then what we call the high byte next. Okay, that's just to clear the screen. Strictly speaking, we don't need to do that, but it's just going to make it tidier. Now we're going to load X with immediate 0, and that's just like the previous program, setting the X register to 0. Next, we're going to load the accumulator, but instead of loading from something like text, we're loading directly from these memory addresses, because labels, we can't do something like text and define that. We just have to actually have hard-coded memory locations. So C100 is where we already stored that hello world string. So we're just going to access that. As before, we're going to use indexing, comma X, which is whatever the current value of X is added to this base address, and it's currently 0. So this is going to load the H of hello world. And now we're going to branch if equal ahead, and we actually don't know where we want to branch. Before we were able to go to branch if equal to done, but again, we have no labels here. And when you're branching ahead, you just actually have to guess. So I'm just going to, I think, incorrectly guess C020. That's some ways ahead, and we can fix that later. In case it's not clear, you might just want to stick with the Turbo Macro Pro way of doing this, but you might find this educational. This is actually how I learned to do assembly language programming in this environment, and Turbo Macro Pro seemed like absolute luxury. So this branch if equal This is if we've reached that null termination, the end of the string. We'll branch ahead to done. I made a mistake, so I just cut something out. So continuing with assembly at C00C, now that we've got that screen code in the accumulator, we want to store it to the screen. And as we learned earlier, that starts at 0400 hex. And again, we want to index that with the X register. So as X increments, it's going to display one character over each time. And then we're going to increment X. And we're going to branch if it's not equal 0. This again is like a branch always. Back to C007 right here, which loads the next character. Now that X is equal to 1, this will load the second letter, like HE now, E, from C101, because the value of X is added on. And now we're done. Return from subroutine. We're going to look at the code. Of course, we still have to fix that one thing here. When we're looking for that 0 byte that terminates the hello world string, right here, we guessed C020, but really the correct address is just here, this return that we're done, C012. So we're just going to modify that, C012. And now we'll disassemble it. And you see, once we reach the 0 byte, it's going to branch ahead to C012, which will return right here. Oh, I didn't have to press return on that. Okay, and we can just make sure that our string is still there. And there's the hello world string in memory, the screen codes for it. Okay, so we can exit out of SuperMON. And now we should be able to sys 49152, which is the same as C1000 hex, and it should display hello world for us. There we go, hello world. And we can re-enter SuperMON with sys 38169, and there's our program. Okay, so it's similar to the other one. The main difference is that instead of calling JSR FFD2, which prints a character to the screen, we're actually storing it directly in screen memory, which is faster, but sometimes just being able to print is nice. But most video games would use something closer to this approach where you just store directly in screen memory, bypassing the slow print routine. But if you're not worried about performance, it's usually better to use the print routine, as it gives you access to doing things like screen clears, other formatting, takes care of scrolling the screen for you if you're doing some kind of program that you want to just keep scrolling. It's kind of a trade-off. And of course, you can use this kind of code in Turbo Macro Pro. I'm just showing you different environments and different code techniques for Hello World at the same time. Okay, exiting out. Okay, so we've looked at assembly language in Turbo Macro Pro. We've looked at what we might call machine language in SuperMON. And now, well, yeah, basically the lowest level is what we might call machine code, which is just programming in hex bytes. But we can make it just a little bit easier, and I'll show you here. Example3.basic. I'm not going to type this all in myself, but I'm going to load this program. / by the way, is the shortcut for the load command. And we'll list it here. So what this is what we might call a basic loader that pokes machine code bytes into RAM and then allows us to execute them. Actually, this is really where I got my start. We're kind of regressing through time here. This is kind of time travel. And you're seeing simpler and simpler ways of programming, or less and less advanced ways of programming, which obviously are in a lot of ways more tedious as well. But being aware of this, I think, is still kind of useful. Okay, so I'll walk through this program so that you just get an idea of what's happening here. We're going to open up with a remark, hello world, and this is actually what I'm using as the string storage. I'm putting it in a remark command at the beginning of the program so our little machine code program can find that hello world string and display it. And we'll see a little bit better how that works in a bit. I'm defining the variable S to 49152, which again is where the machine code is going to start, S for start. And so we're just going to put in memory, same location as we did for the SuperMON example. Now we're going to read the data statements into variable A, and the data statements are down here. We'll look at those soon, but they're just a number from 0 to 255. And if A is less than 0, then that means we're at the end of the program. That's like a sentinel byte. And that's that -1 way down here, end of program. Then we're going to sys the program, that is call the machine code that's being loaded through this basic program. And then we're going to end. But if it's not less than 0, then it's a valid machine code byte. We're going to poke that into memory location S plus I. I is currently 0. And we're just going to poke that A into memory. So then we're going to increment I to look at the next byte and go to 30, branch back up here to read the next byte. So we're just poking consecutive bytes into memory. And once we're at the end, we're going to call that machine code with this command. So that's the basic loader section. Now these remarks are going to just explain a few things. The basic program starts at memory location 0801. When you type in a basic program on the C64, it starts being stored in memory at location 0801 byte by byte. You don't see it, but there are 2 bytes stored for a 16-bit pointer to the next line of basic. Then there are 2 bytes for the line number, because you can have a line number up to 63,999, which takes 2 bytes, 16 bits. So we've already used up 4 bytes here. Next is the REM command. It doesn't use 3 bytes, it just uses 1 because it's tokenized, but it does use 1. And then there's 1 byte for the quotation mark right here. And then the actual string starts. So all this is just an explanation of how I've calculated that in memory. We go to 0801 plus 6 for these 6 bytes explained here, 2, 4, 5, 6. So that means the text string starts at location 0807. Our machine code program needs to know that so it can actually print this particular string, not print garbage from elsewhere in memory. Okay, with that, our explanation ends, and now we're going to have these data instructions. And at the right here, I've got the actual machine language that I want. I want to load the accumulator with value 7, that is the low byte of the text string. So there's a comment here, low byte text, and I've hand assembled that into the appropriate bytes 169, 7. 169 means load immediate, and 7, of course, means the value 7. You've seen before, Turbo Macro Pro, you type this assembly in, and it turns into the correct machine code bytes, or even SuperMON did it right before our eyes as we typed return. In this most primitive example, we're putting it in remarks just so we know what we're doing, but we have to manually assemble. Well, how do you do that? You can just look it up. If you grab the Commodore 64 Programmer's Reference Guide, there are tables in it, and I'll show it on screen, which have all these codes. Now, it may be in hexadecimal, and you have to convert it to decimal, or you can use the excellent Transactor, the complete inner space anthology, and it has all the values in decimal and hexadecimal, so you can use those tables. I'll show those on screen, and I'll put links to those on archive.org or elsewhere where you can read those for yourself. So the next command we want to do is load the Y register with 8, which is the high byte of the text address. The machine code for that is 160 decimal for the load Y immediate, and 8 means put that 8 value into the Y register. Okay, so A and Y essentially now have a 16-bit pointer in them, and that doesn't really mean anything on its own, but that's what the next part means. JSR AB1E. This AB1E is the address of a routine in the basic ROM, which will print a string that's pointed to by the combined A and Y that we've set up here. JSR AB1E, and so the machine code for that is 32, which is 20 hex for a JSR. And again, the low byte and high byte. This 171 represents AB hex, and the 30 represents the 1E hex. And of course, you can use a calculator to convert between decimal and hexadecimal if you're having trouble with that. There's one built into all the major operating systems now, and they have a hex mode in them, or just use an old school calculator. And finally, we're done the program. RTS, return from subroutine, is 96.60 hex. And there's that -1, the sentinel byte, to show that we're at the end of the program. This is yet another way of printing a string on the Commodore 64, but it relies on not only the kernel ROM, but the basic ROM, a direct call to it. And I use this because this is actually the simplest or shortest program I could come up with, and that made it a bit less tedious to translate into machine code by hand. Well, I say by hand, we're using this basic framework to make it a little bit easier on ourselves, but not much. Okay, so we're going to run that, and that will quickly assemble or poke that machine code into memory, and it should execute. Run. Hello world. There it is. So that worked. I typed run, and it executed this basic, which put the machine code in memory, and then executed it here. Yes, that's a very roundabout way of doing it, but maybe that was still instructional in some way. Before I even had SuperMON, I actually was just trying to poke machine code into memory with this sort of hand assembly. Okay, that's it for now. I hope you found that helpful or instructional. Make sure you do check out the video description for links to many of these things I talked about. Thank you very much to my patrons for their support. Thank you for watching, and we'll talk to you next time.